guys, so in this series of videos I will be talking about bonding. So the three types of bonding that we'll be talking about, we've got metallic bonding, which you'll find in metals, ionic bonding, which you will find between metals and non-metal elements, and then covalent bonding, which you'll find between non-metal elements. So if you're a bit unsure about what element is a metal, what element is a non-metal, I've got a periodic table just in this bottom corner down here. So on your left hand side, this is where you'll find your metals, and on the right hand side, this is where you'll find your non-metal elements as well. So it is important that you know which elements are metals, which elements are non-metals, so you get the right type of bonding involved. So we're going to start off with metallic bonding here. So I've got sodium as an example, found on the left side of the periodic table. It is a metal. So sodium has an atomic number of 11, so 11 electrons, as well as 11 protons, and 1 electron in its outer shell. So with metals, they lose their outer electron, so sodium loses its 1 outer electron. So electrons are negative, so we've lost some negative charge. So our sodium atom becomes a positive sodium ion. We've only lost 1 electron, so it's just a 1+ ion. So these ions in metals kind of form some nice, neat rows. So they're just not just 2D shapes, this is a 3D shape, and it is a regular arrangement of these positive ions. So as well as the positive ions, we also have the electron that each ion has lost, and those electrons just surround the positive ions that are in there. So as I've mentioned, these ions are regularly arranged in these neat rows into a giant 3D structure that is known as a giant metallic lattice. So giant because lots of ions and lots of electrons are kind of involved, metallic because metallic bond is involved, and lattice because it is just a regular arrangement. So with metallic bonding, what type of what's keeping this structure together? So it's the attraction between those positive ions and the negative electrons. So with metallic bonding, it is an electrostatic attraction between positive metal ions and the negative electrons. So I'm just going to do another example for you. So this time we've got magnesium. So magnesium has 2 electrons in its outer shell that it loses. So this time, rather than having a 1+ charge, our magnesium, it becomes a 2+ ion. So all these ions present in our metallic lattice, there are 2+ ions now, and that means we also have 2 electrons that have been lost per ion. So we end up having more electrons surrounding those ions than we did in the sodium structure. So for every positive ion, we'll have 2 electrons present. So the more electrons that are lost from the atom to make the ion, the more electrons that you'll find in the structure. So just to mention this, these electrons are known as delocalized electrons. and that's just mean that they're just not local to a particular atom, they're not tied to a particular atom. These electrons are allowed to move freely throughout the structure.